Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, for the function, check for discontinuities and make a rough sketch of the curve. Now the given function is y equals 2 plus x times 3 minus 2x over x squared minus 3x. So as you can see, this is a rational function. And a rational function has discontinuities in the form of a whole or vertical asymptote. So the first step we should do is to factor this rational function as much as possible. Now we cannot do any factoring in the numerator, but we can do common factoring in the denominator. So we can factor out an x in the denominator. So in the denominator, we get x and then parentheses x minus 3. So now we can see that there is no common factor in the numerator and the denominator. So that means this rational function has no poles. Now we can do the analysis for vertical asymptotes, and for that we can set the denominator factors equal to 0 and find the equation of the vertical asymptote. So the first one is x equals 0. So that's our first vertical asymptote in this rational function. And for the second one, we do x minus 3 equals 0. And then we add 3 to both sides. So the 3's on the left side get cancelled out. So we get x equals 3. So this is our second vertical asymptote. So in this rational function, there are two vertical asymptotes, x equals 0 and x equals 3. Now we have to analyze the behavior of the curve around these two vertical asymptotes. So for that, we should find the sign of the limit on the left and the right hand side of these asymptotes. So let's start with the vertical asymptote x equals 0. So we'll do the left hand limit. Limit x approaches 0 from the left side. 2 plus x times 3 minus 2x over x parentheses x minus 3. Now we are not interested in the value of the limit. We want to know whether this limit gives us a positive or a negative result. So for that we'll have to use a test value to the left side of 0 but very close to 0, like negative 0.1. So if we sub in x as negative 0.1, so the first expression 2 plus x becomes positive. So it gives us a positive result, and from the second parentheses we'll again get a positive result because 3 minus 2 times negative 0.1 will become 3 plus 2 times 0.1, and in the denominator so x will be negative and x minus 3 will also give us a negative result. So that means it will be positive over positive. So overall we'll get a positive result for this left hand limit. And now we can evaluate the limit on the right side of x equals 0. So limit x approaches 0 from the right side, and then 2 plus x times 3 minus 2x over x times x minus 3. Now if we sub in an x value to the right side of 0 but close to 0, like 0.1. So the first parentheses in the numerator will give us a positive result, and we'll get a positive result from the second parentheses. Now in the denominator, x will be positive, but x minus 3 will give us a negative result. So we'll get positive over negative, and the overall value will be a negative value. So now we can use this information to write the behavior of the curve around this vertical asymptote. So as x approaches 0 from the left side, y approaches positive infinity. And as x approaches 0 from the right side, y approaches negative infinity. So this is the conclusion for the behavior of the curve around the vertical asymptote x equals 0. Now we can do the analysis for x equals 3. So we'll start with the left hand limit. So limit x approaches 3 from the left side. So 2 plus x times 3 minus 2x over x times x minus 3. Now if we sub in an x value which is just to the left side of 3, the one test value can be 2.9, and if we sub in x as 2.9 in the first parentheses, we get a positive value, and in the second one we'll get a negative value, because 3 minus 2 times 2.9 will be 3 minus a number bigger than 3 over, now x will be positive, and x minus 3 will give us a negative result, because 2.9 minus 3 will be a negative value. So we'll get negative over negative, but we'll get an overall positive value. Now we can analyze the right hand limit. So limit x approaches 3 from the right side. So 2 plus x, and then 3 minus 2x over x times x minus 3. So for this limit, we should use an x value to the right side of 3 but close to 3, like 3.1. So now in the numerator, the first parentheses will give us a positive value. The second parentheses will give us a negative value. In the denominator, x will be positive, and the second parentheses x minus 3 will also give us a positive value. So we'll end up with a negative over a positive, which will give us an overall negative value. So now we can conclude about the vertical asymptote at x equals 3, that as x approaches, so I can write the conclusion. So as x approaches 3 from the left side, y approaches positive infinity, and as x approaches 3 from the right side, y approaches negative infinity. So now we are done with the analysis for vertical asymptotes. So the next step is to find the intercepts for this rational function. So we can start with the x-intercept. So for x-intercept, we should sub in the y as 0 in this given function and then solve for x. So we can use the factored form. So it's 2 plus x times 3 minus 2x over x Now we can cross multiply the denominator because we have to solve for x. So 0 times x minus 3 will become 0. So we get 0 equals 2 plus x times 3 minus 2x. So we get two cases. So the first case is 2 plus x is equal to 0, and we can isolate x by subtracting 2 from both sides. So the 2's on the left side will get cancelled out. So we get x equals negative 2. So that's our first x-intercept, which can also be written as negative 2, 0 as an ordered pair. Now we can analyze our second case. So 3 minus 2x is equal to 0. So now we can isolate x. So we have to subtract 3 from both sides. So the 3's on the left side get cancelled out. So negative 2x equals negative 3. And now we can divide both sides by negative 2. So the negative 2's on the left side get cancelled out. So we get x equals positive 3 over 2. So this x-intercept can be written as 3 over 2, comma 0. Now we can find the y-intercept for this function. So for that, we should sub in x as 0. Now if we sub in x as 0, so y equals, we can use the factored form, plus 0 times 3 minus 2 times 0 over 0 times 0 minus. Now if we simplify this expression, so we get 2 times 3 in the numerator, because in the first parentheses 2 plus 0 is just 2, and in the second parentheses 2 times 0 is 0, so 3 minus 0 is 3. Now in the denominator we have a 0 times 0 minus 3, so 0 minus 3 is negative 3, and 0 times negative 3 will be 0. So we are getting a 0 in the denominator because there is a vertical asymptote at x equals 0. So that's why there is no y-intercept, because when we have a 0 in the denominator, the expression will become undefined. So there is no y-intercept. And that's because there is a vertical asymptote at x equals 0. So the y-axis is a vertical asymptote. So now we are done with intercepts. So now the next step is to analyze the critical points for this function. Now critical points are points at which the derivative of the function is equal to 0 or undefined. Now this given function is a rational function. It will be easier to find the derivative of this function if we distribute the terms in the numerator. So we can use the FOIL method. So we can rewrite the given function. So if we distribute the terms using the FOIL method, so 2 times 3 is 6, and 2 times negative 2x is negative 4x, and then 3 times x is 3x, and then x times negative 2x is negative 2x squared over x squared minus 3x. So now we can simplify this expression by combining like terms in the numerator. So in the numerator we get negative 2x squared minus x plus 6 over x squared minus 3x. Now we can find the derivative of this function using the quotient rule. So y prime. So for quotient rule, so we start with the derivative of the numerator. Now the numerator is a polynomial function here. So we'll have to use the power rule. So in the first term, so -2 is the coefficient. So it will stay as it is, and the derivative of x squared is 2x. And the derivative of -x is -1 in parentheses. Now the derivative of 6 is 0 because 6 is a constant, so it goes away. Then times the denominator, x squared minus 3x, minus the numerator, and the numerator expression is -2x squared minus x plus 6 times the derivative of the denominator. Now in the denominator, the first term is x squared, so the derivative will be 2x. Then minus the derivative of 3x will just be 3 over x squared minus 3x squared. Now we can simplify this expression. So in the first parentheses, we just get -4x minus 1 times x squared minus 3x. And then in the second part, so it will just be -2x squared minus x plus 6 times 2x minus 3 over x squared minus 3x squared. Now we can simplify the numerator, so we can distribute the terms using the FOIL method. So I can do the calculation on the side, so that will save us some space. So if I do -4x minus 1 times x squared minus 3x, so we use the FOIL method. So -4x times x squared is -4x cubed. -4x times -3x is plus 12x squared. -1 times x squared is -x squared. And -1 times 3x is -3x is positive 3x. Now we can combine these terms. So positive 12, yeah. So we get -4x cubed. So we are combining like terms plus 11x squared plus 3x. Now we can simplify the second part. So in the second part, we have -2x squared minus x plus 6 times 2x minus 3. So we'll have to use the FOIL method here as well. But here we have 3 terms in one expression, so we'll have to do it 3 times. So -2x squared times 2x is -4x cubed, and -2x squared times -3 will be plus 6x squared, and then -x times 2x will be -2x squared, and -x times -3 will be plus 3x, and then 6 times 2x will be plus 12x, and 6 times -3 will be -18. And now we can combine like terms. So if we combine the like terms, we get -4x cubed. Now we can combine the x squared terms plus 4x squared, and then plus 15x minus 18. Now we can subtract these two results. So it will be -4x cubed plus 11x squared plus 3x, and then when we subtract, so the sign of the terms in the second expression will change. So we get plus 4x cubed minus 4x squared minus 15x plus 18. And now the x cubed terms can get cancelled out. So now we can combine the like terms. So 11x squared minus 4x squared is 7x squared. And then 3x minus 15x is negative 12x. And then plus 18. So this is the expression we get for y prime. So now we can write, so y prime is equal to, so 7x squared minus 12x plus 18 over x squared minus 3x squared. So now we have to find the x values for which y prime is equal to 0. So we can sub in the left side as 0. So 0 equals 7x squared minus 12x plus 18 over x squared minus 3x squared. Now we can cross multiply the denominator. So we get 0 equals 7x squared minus 12x plus 18. Now this is a quadratic equation whose discriminant is less than 0. So if you calculate the discriminant, so b squared minus 4ac, so that will be negative 12 squared minus 4 times 7 times 18, which gives us a negative value. That means this equation, this quadratic equation has no solution. That means there are no x values at which y prime is equal to 0. So there are no critical points at y prime equals 0. Now we can do the analysis for y prime being undefined. So y prime will be undefined if the denominator becomes equal to 0. So we'll get the same result that we got for vertical asymptote. So that means we don't need to do the analysis for y prime becoming undefined because we have found the vertical asymptotes and we have also found the behavior of the curve on both sides of these vertical asymptotes. Now next we can find the horizontal asymptote in this function. So for that we'll have to modify this function. So we should use the distributed form of the function for that we got for critical points. So I can highlight it. Now in this expression, the degree of the denominator is equal to 2 because that's the highest power on x in the denominator. So to find the horizontal asymptote, we'll have to divide each term in the numerator and the denominator by x raised to the degree of the denominator, which is x squared. So I can do the analysis here. So we are doing the analysis for horizontal asymptote. So we have to divide each term in the numerator and the denominator by x squared. So we get negative 2x squared over x squared and then minus x over x squared plus 6 over x squared over then x squared over x squared and then minus 3x over x squared. Now in the numerator we can simplify the first fraction to just negative 2 and in the second one negative 1 over x, and the third one stays as 6 over x squared. And in the denominator we get 1 minus 3 over x. Now we can apply the limit x approaches infinity. So we get negative 2 minus 1 over x plus 6 over x squared over 1 minus 3 over x. Now if we apply the limit, so we get negative 2 minus 1 over infinity plus 6 over infinity square over 1 minus 3 over infinity. Now we know that 1 over infinity is equal to 0. So in the numerator, we'll be left with just negative 2. And in the denominator, we'll just be left with 1, which is equal to just negative 2. So that means the horizontal asymptote for this function is at y equals negative 2. Now we have to analyze whether the graph approaches this horizontal asymptote from above or below on the left and the right hand side of the x-axis. So now we can continue on this new page. So now we have to do the analysis for horizontal asymptote, whether the curve approaches the horizontal asymptote from above or below. So let's start with the analysis on the left side. So we'll use a big negative number. So limit x approaches negative 100, so then 2 plus x times 3 minus 2x over x times x minus 3. Now if we sub in x as negative 100, so if we apply the limit, so we get the 2 plus negative 100, 3 minus 2 times negative 100 over negative 100 times negative 100 minus 3. Now we have to see if the value that we get from this expression, is it greater than negative 2 or less than negative 2, because we found that the horizontal asymptote is at y equals negative 2. So we got negative 200, in the first parentheses we get negative 98, and in the second parenthesis, so negative 2 times negative 100 is positive 200, so 203 over negative 100 times negative 103. Now we can evaluate this expression. So negative 98 times 203 divided by negative 100 times negative 103. So I got negative 1.93, which is greater than negative 2. So that means the curve approaches horizontal asymptote from above on the left side. Now we can do the analysis on the right side. So for that we can use limit x approaches positive 100, so 2 plus x, then 3 minus 2x over x times x minus 3. So now we can apply the limit. So we get 2 plus 100 and 3 minus 2 times 100 over 100 times 100 minus 3. So in the first parentheses we get 102, and then in the second parentheses 2 times 100 is 200 and 3 minus 200 is negative 197 over 100 times 97. Now if we evaluate this expression, so 102 times negative 197 divided by 100 times 97. So I got negative 2.07, which is less than negative 2. So that means this curve approaches horizontal asymptote from below on the right side. So this is the conclusion for the horizontal asymptote analysis. So now we can use all of our results to sketch the function. So let's start with the vertical asymptotes. So the vertical asymptotes are at 0 and 3. So this is our first vertical asymptote, and we can assume 3 is here, and so this is our second vertical asymptote. Now as per the end behavior we got around the vertical asymptote, so on the left side of x equals 0, the end behavior is towards positive infinity, and on the right side of this vertical asymptote it's towards negative infinity. Now for the other vertical asymptote to the left side, it's positive infinity, and to the right side it's negative infinity. Now we can plot the x-intercept. So the x-intercepts we got are negative 2, 0 and 3 over 2 comma 0. So the first x-intercept can be shown somewhere here, so negative 2, and then the second x-intercept can be shown somewhere here, so this is 3 over 2. Now there are no y-intercepts and no critical points at which the derivative was equal to 0. Now the next is to show the horizontal asymptote at y equals negative 2. So let's assume this is negative 2. So the horizontal asymptote can be shown like this. Now we can show the behavior around the horizontal asymptote. So on the left side, the the curve approaches horizontal asymptote from above. So like this. And on the right side, from below. And now we can join these end behaviors to get the sketch of the function. So we should make sure that we pass the sketch through all the intercepts. So on the left side, the curve can look something like this. So the curve can look something like this. And then on the right side, the curve can look something like this. So this should be the sketch of this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.